Hey Stats class, we're going to look at a couple of examples of doing a hypothesis test about the claim value of a population proportion. Alright, so the first thing you want to do is open up Desmos, type in normal DIST, that's your normal distribution command like you use to find probabilities of a bell curve, like normal probabilities. Now for the mean and standard deviation, you want to use the claim value of the population percentage. That's the 26%, not the 21%. So make sure the one you're grabbing is the claim value, which is the population proportion, which is the one that is the mean of the sampling distribution of the sample proportion. And then the standard deviation of the sampling proportion is going to be equal to the square root, so SQRT in Desmos is square root. Do a division because you got a fraction underneath the square root. And then you're going to pick P again, that's the 0.26, and then you can do a parentheses and do 1 minus P, or you can just subtract that out on another line and get that number. But that number is Q, so P times Q, and then you're going to divide by the sample size. So that's 100, so that's our sample size there. Alright, and then I'm going to zoom in on that, and then we'll start answering these questions. There's my bell curve. I'll blow it up in just a second so we can see it. Alright, so the first thing it asks us to do is to identify the null and alternate hypothesis for the test. Now notice there's nothing that says greater than, less than, okay? It just says equal to in the first line. There's no direction implied for the alternate hypothesis. So that's going to be a not equal to. This is going to end up being a two-tailed test. So that's going to be choice C for us here. Okay, and now let's move on and wants to know the test statistic for the hypothesis test. Remember, that's just a z-score. We're going to try to find a z-score for this. So the test statistic is going to be your sample sample proportion. So that's 0.21 minus the claim value of P, so that's the 0.26. And then we divide by the standard deviation, which is this big thing right here. All right, the standard deviation is the denominator for all of these. It's just this happens to have a fraction within that fraction. So there is our test statistic, or our z-score, for that sample proportion. All right, and they want us to run it to two places, so that's going to be negative 1.14, since that next number is a 9. All right, and then they want us to find the p-value. So there's two ways to get the p-value. Yeah, actually more than two ways, but two ways that are pretty straightforward. Number one, you could do the normal distribution again, open parentheses, and just use the standard normal distribution. So this previous value is a z-score. Right, the test statistic is a z-score. You could do outer and then do this number for the low number, negative 1.14, and then its opposite, positive 1.14, for the upper number. You know, that's one way you could do it. That's our p-value. I'll put it down here just so you can see it. All right, the other way that you can do it is to use the original distribution. Let me turn this one off. Do the original distribution. So I would do a left because it's below, and in the spot here where it's giving me the number, I would put the sample proportion, 0.21. All right, now this is just the left tail. If I click this bottom number down here and get that probability, that's this area in the left tail, but because it's a two-tailed test, I would double it, so times 2, or 2 times that number. So I get the same thing there as I get here. You can see those two numbers are roughly the same, okay? But for the number of places that we have to round this one to, they'll match, okay? So that's one way you could do it. About the standard way, the way that you're expected to do it, I'm going to turn this one on and zoom in around it, and then turn this other one off, just because that is the more traditional way to do it with the z-scores and the z formula. And it makes it a little easier with these two numbers because they are opposites of one another like these are. So either way you want to do it is fine. You just have to remember you're going to go into the tail that you're closest to. So when I did it with this one, my p hat was below p, so I went further into the left tail. So if I had gone, if I had been to the right, for instance, I would use the right, and that's into the right tail, and that's that same number. It's just doubled down here to get the probability. So that, you know, that's the way that you approach these, the two different ways that you can approach these. But the more traditional approach is to use to get a p-value, is to use your test statistic with the appropriate distribution, normal in this case, and then use outer area. Put the z-score that you got, if it's negative, put it in the left one. If it's positive, put in the right one. But in the other position, put the opposite of that number, and that will be your p-value for a two-tailed test.